Here's another question on linear combination and spanning set. By now you've done many, but this is kind of unique, and what you're going to learn here is something which you may find in books with a lot of difficulty. But you may get across this question in your test paper. So it's worthwhile going through this video and understanding the concept. Question here is, can every vector in xy plane be written as a linear combination of vector u and v, where vector u is 1, 7 and v is 4, 2? Now this is a straightforward question, since they are not zero vectors and since they are not collinear, so they can span. So they form a spanning set in R2. So therefore, every vector in xy plane can be written as a linear combination of u and v. Part B is, write a vector w which is 2, 16 over 3 in terms of u and v. And part C is, does w terminate on the line through the endpoints of u and v? Explain. So mainly it is because of this question that I'm trying to share this problem with you, right? So what I'll do is I'll leave the first two parts of this question for you to solve, as we have done many examples, and start off with the main part, which is, does w terminate on the line through the endpoints of u and v? Explain. So let's try to understand what is this talking about. Now when you solve part B, then you will get an answer. So let me write down the answer for part B, which is w is equals to 2 over 3 u plus 1 over 3 v, right? It's kind of important for me to give you the answer so that I can solve or explain you part 3, which is, does w terminate on the line through the endpoints of u and v? Explain. So this is what we're going to learn today. So to explain this, let me first sketch and show you what are we seeing here, right? So we have xy plane here, and since all points are positive, so I'll take that advantage and just draw the first quadrant, right? And I'll be slightly more accurate than what I had been in past. So we want to plot a point u, which is 1, 7. So let's say scale is like this: 1, 2, 3, 4, 5, 6. That is my 7, right? And on this side we are going up to 4. So let's go up to 4 here. So it's like 1, 2, or should we take longer? I'm just debating. So because that may be okay, let's 1, 2, 3, 4. Okay, so that is kind of short. So what I'll do is I'll make a bigger scale for the horizontal. That means I'll take this as 1, 2, 3, and 4. Okay. Now, so we have, you can see different scales for 2a and b, right? Let's plot the vector u, which is 1, 7. So when we say 1, 7, so 7 is this point for us. So this is my 1, 7. 1, 7. So that is my vector u, right? So let me plot this point, and vector u is like this. And vector v is 4, 2. So 1, 2, 3, 4. And I've taken these much smaller, so it's kind of here. So I have vector v as 4, 2. That is my vector v, probably the best line I've drawn. And vector w is 2, 16 over 3. So vector w is 2, 16 over 3. So we got 2 and 16 over 3. I don't know where it is going to be, but somewhere here. Now let's look into the question once again. The question says, does w terminate on the line through the endpoints of u and v? So it is asking me that if I connect these points, then will w terminate on that line? That is what it is asking me, right? So what I will do is I'll just connect these lines. So is this w? Does w terminate on the line through the endpoints of u and v. Explain. So the question is this my vector w? So that is the question, right? So this is what we need to answer. Now you will see the interesting part here is that w is equal to, as we did here, w is equals to 2 over 3 u plus 1 over 3 v. Now if you add these terms a and b, where a, this number is a for you, right? And this is b for you. If you add a and b, what do you get? Let's do that. So what do we get? We get 2 over 3 plus 1 over 3 is equals to 3 over 3, that is 1. You will notice that whenever the sum of these two scalar multiples is 1, then always your vector will be on the line segment joining u and v. That is what you'll always see. So what I'm trying to say here, that in this scenario, you'll find that w is 2/3 of u. This is my vector u, right? Now 2/3 of u will be, I'm just trying to get the answer from here. This is like, let's say 1/3. These are 1/3, for example, right? So this point will be 2/3. Let me divide this in 3 portions. So if we draw like this, so this will be 2/3 of u. And if I divide this into 3 parts, then you will notice that it will this will be 1/3 of v. So this is my vector v, and that will be 1/3 of my v. And when I drew this, I'll get w here, which is actually linear combination, as you can see, of 2/3 of u plus 1/3 of v. And always, if a and b add up to 1, then you'll find that w will terminate on the line through the endpoints of u and v, as I have shown you here in the diagram. So with this example, I really wanted to highlight you that if I give you a question or ask a question that will this vector terminate on the line joining the other two vectors, then if you get a plus b as 1, then the answer is yes, it will, right? So it actually divides u and v in a ratio. Do you see that? And that is what it is. So this is a very interesting question and asked in so many different ways, and I hope this video helps you to answer that part. And I'll appreciate that you answer all other questions. Go through this, get this answer on your own, and add this explanation. I have another video here where I haven't answered this question, and I think this explanation helps you to answer that question. Thank you.